So today we're doing section 7.4, and this is solving linear systems using elimination, but we have to do multiplying first. So let's see what happens here. I'm going to give you an example. So these are some examples. Uh, 2x plus 3y equals 5. Will you take it outside the door until I'm done, please, Jack? Will you go outside the door until I'm done, please? Thanks, sweetie. Okay. Shh. Okay. So if I just used my solving with elimination method that we did for both Mondays and Fridays assignment, so if I just added these two equations together, I'd get 8x plus 8y. My x's and y's would not go away. Or if I tried subtracting these two equations, I'd get 4x plus 2y. My x's and y's don't go away. So I have to use a different trick for doing this, for doing elimination. Now, what you have to notice is that if you wanted to eliminate the x's, if this bottom row had -6 instead of 2, then you could just add the two rows here, and then the x's would be eliminated. So I'm going to make this second equation have as its coefficient, as its first number in front of the x, to be -6. And to do that, I'm going to multiply this whole equation by -3. If I do that, then this second equation becomes -3 times 2x is -6x. -3 times positive 3y. Negative times positive is negative. 3 times 3 is 9y. -3 times 5 is -15. Be sure to put in my equal sign. And that's fair to do if I multiply both sides of the equation by the same number. So I've multiplied every term in this equation by the same number. So this equation has actually the same value. And then I bring the other equation down, the first equation down, and write it right below. 6x plus 5y equals 19. Now if I just add these two equations, the x's eliminate, they go away. -6x, positive 6x is no x's. -9y, positive 5y is -4y. -15 plus 19 is positive 4. Now I can solve for y. Divide both sides of this equation by -4. And I get y equals 4 divided by -4 is -1. Yes? So you have to look at the coefficients, the numbers sitting next to the x and y, and see if there's any easy number you could multiply this 2x by to get 6, and I really want to get the opposite of 6, so I want to get -6. Or is there a number I could, a whole number I can multiply 3 by to get -5? You always want the opposite because you want the variable to eliminate, and it's easiest if you eliminate with addition rather than subtraction. Yes, sir. So I look here at this 6 on the top row, and I would like the number below it to be negative 6. So I think, oh, is there some whole easy number I could multiply 2 by to get negative 6? If there is, that's the one I use. If I can't get both the x's to be 6, maybe I could get both of the y's to be 5 and negative 5. So then I think, oh, is there any whole number I could multiply 3 by to get 5? No. So it's going to be easier to try to do the x's. We'll do eliminations where it gets even harder, where there won't be some easy number to multiply by, and then I'll show you a little bit more sophisticated technique. Now that I have the y solved for, I'll do a lot of examples of these, Brandon, so that you see how we do these, because it's like we're into new territory here, obviously. Okay, so I'll explain my thinking as I go through each one of the problems. So now I got to get my x, and I can use either one of the black equations or the red equations to substitute this negative 1 back into to get my x. So I think I'm going to use the second equation, just because the numbers seem a little smaller here. So this said 2x plus 3y equals 5. Y is negative 1. So I change this to 2x plus 3 times negative 1 equals 5. So that's 2x plus 3 times negative 1, oh, that's negative 3, or 2x minus 3 equals 5. Add 3 to both sides of this equation and get 2x equals 8. Divide by 2 and get x equals 8 divided by 2 is 4. So my answer is x is 4, y is negative 1, or I can write this as parentheses 4 comma negative 1. Okay, we'll do another one of these. So let's go. I got quite a few examples here. I want to make sure I get easy numbers. That one has easy numbers. Okay. Let's try this again. I'll explain my thinking as I go through. So I got 4x plus 5y equals 35, and negative 3x plus 2y, negative 3x plus 2y, that's not the one I want to do. Okay, never mind. Sorry. I don't want to get one with real hard numbers yet. So let me go back and find a better example. I don't want fractions. Here we go. Sorry. Pen. 2x plus 5y equals 3, and 3x plus 10y equals negative 3. Here we go. This will work. Alright, so now I look at the numbers in front of the x. 2 and 3. Is there a whole number I can multiply 2 by to get 3? Nah. Look at the coefficients for the y's. 5 and 10. Is there a whole number that I can multiply 5 by to get 10? 2. Okay, so I don't actually want it to be 10. I want it to be the opposite of 10. So I won't multiply by positive 2. I'm going to multiply by negative 2. So because I want to be able to add this system together and eliminate the variables, otherwise I have to